yes. I was going to say no, but you're right. No, it's yeah. I was thinking, yeah, of the velocity, so v. So this one, right, now this guy here. So the speed, speed is equal to the magnitude of the velocity. I called it v. I don't know why I did that. Okay, I guess v for velocity. But this is v, right? This is your v. And this is a of t. This is your acceleration, right? So it's the square root. This is the cool part. It's the square root of, I guess, this thing squared, right? So cosine squared of t over 2, cosine squared of t over 2, plus, and this does include the negative, but the negative will go away. So it's negative sine t over 2 quantity squared. Okay, t over 2 quantity squared. Okay. So you get cosine squared plus sine squared. What is that going to be? 1. So you get the square root of 1. So it's equal to 1. So that's the speed. So in theory, the problem is done. But now this is the cool part. But before you go further, any questions on speed? Yeah.
With the sign,
Mhm.
it doesn't matter with the power.
Right.
Right, because it's still. I mean, you could still do negative sine squared of t over 2.
Yeah, it'll be, the negative goes away with the 2. Yeah, the 2 gets rid of the negative. Because it becomes this. It becomes a good question. It becomes cosine squared of t over 2 plus sine squared of t over 2. Whoops, almost messed up. And cosine squared plus sine squared is 1. Yes.
So we can just jump straight to
Yeah, you can just jump straight to 1. Absolutely. Good question. Good. So here's the deal. Anyone know what the graph of r of t is? Anyone know? Big leap. Anyone? The graph? Like if you graphed it? Yeah, circle. Yeah, it's a circle. This is a circle. This is a circle of radius, like 2. It's a circle. It's a circle. So here's the idea. This is what's going on. Let me come to this board and explain it. It makes it much bigger here. So here's the idea. So here we have a circle. Right? It's a circle. There's a particle moving along the circle. I don't remember which way it's going. Is it going this way? I think it's going this way. Let me see if I wrote it on my notes. Yeah, I did. So it's going this way. Right? So it's going this way. It's going that way. Okay? And so let's say you found the tangent vector here. That's the tangent vector. The tangent vector is also called the velocity vector. Yes! So that's v. So here's the really cool thing. The speed is constant, right? So whenever the speed is constant, does anyone know where the acceleration vector will be?
0.
Nope.
No.
Go ahead.
0.10.
Yes. How did you know that?
Physics.
Oh, some intelligence. Oh, cool. Yes. So that's the acceleration vector. So it turns out that whenever you have circular motion at constant speed, the acceleration vector is always perpendicular to the velocity. So a dot v is equal to 0.
It's only under circular motion.
Only under circular motion under constant speed. I'll explain why in a minute. Yeah, something like that. The physics people call it that. Yeah. Is that what it is or something? Yeah, So you can prove this pretty easily. Okay, you can prove it pretty easily. Notice that the speed is constant. So you can prove that if the speed is constant, that this is equal to 0. I proved it in my notes. It's easy. Mathematically, it's really easy to prove. It's not hard. Does anyone know why it's true intuitively? Can anyone provide like a good explanation? I spent some time like thinking about this, like on my own, like digging deep. Because mathematically, I can prove it in 5 minutes. That's a piece of cake.
Well, I mean, you know that when velocity is constant, acceleration is 0.
Well, velocity is not constant.
Didn't he just say it was?
Speed is constant.
Oh, speed.
The velocity, the direction is changing, so the velocity is changing. Good try, though. Great, good try. Huh? Here's my way of thinking of it. I don't know if this is a good way. It has to be perpendicular, because if it wasn't, let's say it was going this way. Well, here's your velocity. Say it was going this way. Then the object is actually, the acceleration is acting in the direction of motion. So then the speed is going to change. If it's going this way, then it's slowing things down. So the speed is going to change. So the acceleration cannot act in the direction of motion or against it. It has to be absolutely perpendicular to it. So it doesn't speed it up or slow it down. Because if it points this way, here's v. If A points this way, it's going to speed it up. Oh, fail, speed is not constant. If it points this way, it's going to do what? It's going to slow it down. So it must be perpendicular. It took me a long time to think about that, but just to come up with like an intuitive way to like understand this, because mathematically it's not hard. The proof is identical to the proof we did earlier with the dot product. So I wanted to just show you. I get goosebumps thinking about it. It's pretty cool. It's like some heavy physics stuff, right? So.